zero logo blown up, and it represents the situation we face in stopping global warming. There's three stripes you see on the logo, and the leftmost one represents the carbon dioxide we release into the atmosphere as we transition to net zero. And you'll notice from the little arrows there that the slower we are at reducing emissions, the faster we have to reduce emissions in the future, because it's the total amount of carbon dioxide that we dump into the atmosphere, the area under that curve, that determines the temperature we end up at. So if we're slow to begin with, we just have to work harder later in order to achieve the same temperature outcome. If we go to the next slide, this is illustrated by one of these iconic figures from the Intergovernmental Panel on Climate Change, which shows there is a straight line relationship between the total amount of carbon we dump in the atmosphere, that's the horizontal axis here, the cumulative human-induced atmospheric carbon dioxide emissions since pre-industrial times or since the late 19th century, and then the warming that's caused in the vertical. And you see, because it's a straight line, it means the further you go to the right, the more carbon dioxide you dump in the atmosphere, the warmer it gets. And this very simple relationship has a very simple but powerful implication, which is we have to achieve net zero carbon dioxide emissions. We have to stop net dumping of carbon dioxide into the atmosphere in order to stop the warming. If we go to the next slide, we're unlikely to reduce emissions fast enough. At the moment, we are not reducing emissions. There was a small downturn in emissions last year with the COVID-19 pandemic, but emissions have already recovered. So we're not reducing emissions at the moment. We therefore will need to, in order to limit the total amount of carbon we dump in the atmosphere, we need to complement emission reductions in the near term with other ways of taking carbon dioxide out of the atmosphere. And this is why there's a lot of interest at the moment in so-called nature-based climate solutions, planting forests, restoring ecosystems, restoring coastal mangrove swamps, and the like, which allows you to complement, if you go to the next slide, the impact of emission reductions with the impact of, that's enough, with the impact of planting forests to take carbon out of the atmosphere, to offset in the jargon, to offset the impact of our continued emissions. But we have to keep the implications of nature-based climate solutions into perspective. We have to be, they're very popular at the moment. In the last Davos meeting before the pandemic, everybody was talking about the benefits of planting 1 trillion trees and all that sort of thing. But we have to recognize that the impact of even the most optimistic estimates of nature-based climate solutions might be to shave 1/10 of a degree or so off global temperatures by mid-century. This is a figure from a recent paper that I was involved in Nature, which showed that there are benefits from nature-based climate solutions. There's a difference between the dashed lines and the solid lines here, but it's sort of 1/10 of a degree or so. And if you compare that to the fact that fossil fuel emissions are driving temperatures up by 2/10 of a degree per decade right now, you realize that nature can help, but it's not the full solution. We also have to deal with stopping fossil fuels themselves from causing global warming. If we go to the next slide. Thanks. There's another very important limit, and I'm spending a bit of time on forestation because I know a lot of companies are thinking about buying carbon offsets, paying for reforestation in order to compensate for their continued carbon dioxide emissions. So it's important to understand the limits on this approach. And one very important limit is the fact that as the world warms, the biosphere, that's the forests, the soils, the plants of this planet, they start to re-release their carbon back into the atmosphere. Or for example, as permafrost melts, it starts to release carbon back into the atmosphere. And that release, if you go to the next slide, that could add up to about 5 billion tons of carbon dioxide per year by mid-century. So this is a source of carbon dioxide that results from historic emissions. This is not something that we're doing ourselves at the time in 2050, but it's a consequence of all the emissions that have been made over the past century. So we are going to need that 5 billion tons of carbon dioxide per year is actually more or less what we estimate we could achieve with nature-based climate solutions. So we will need all the nature we can get just to keep the carbon content of the biosphere stable. So you can't count on trees being able to compensate for ongoing fossil fuel use after the next 20 or 30 years. So if I have a message for companies using fossil fuels today, it is, yes, it's a very good idea to use nature to offset your fossil fuel emissions right now, but don't count on it as a long-term solution. You have to find another solution to ongoing fossil fuel use from 20 or 30 years time, because we will have to, we will have all the work we can do just to keep nature stable after the middle of this century. We cannot rely on nature continuing to compensate for our fossil fuel emissions going forward into the future. If we go to the next slide, thanks, Kwame. So that shows that, for example, some fossil fuel companies, I'm picking out Shell here. Apologies for mentioning Shell again. Of course, basically these arguments apply to every fossil fuel company. But Shell has been recently sort of advertising that we can drive carbon neutral by protecting and replanting forests. There's a sense in which this is true, but only in the short term. You cannot count on, you can't turn rocks into trees forever. So we cannot count on being able to offset the continued production of fossil carbon dioxide from fossil fuels by planting trees or investing in nature. So it's one of these things where it's a good idea to do it in the short term, but we cannot rely on it in the long term. We need another plan. And if we go to the next slide, the third stripe of our logo refers to what that other plan might be. We need solutions to the production of carbon dioxide from fossil fuels that are permanent, where we have permanent ways of storing carbon dioxide and not dumping it in the atmosphere or relying on forests to mop it up. This is a picture actually of one of the earliest facilities for disposing of carbon dioxide. This is the Sleipner facility in the North Sea, where carbon dioxide is being put back into the Earth's crust. And if we look, if we go to the next slide, this is essentially the answer to how to stop fossil fuels from causing global warming. So, as I said, when I showed you that picture of the Greek church, I said we have to stop fossil fuels from causing global warming. This is how we do it. This is how we do it in the economic models that are used to understand and predict the impact of climate policies that meet our climate goals. And this is the the average of lots of simulations of these economic models that limit warming to about 1.5 degrees. So these are the successful scenarios that actually manage to meet the goals of the Paris Climate Agreement that are considered by the Intergovernmental Panel on Climate Change. And the blue line on this graph shows the total carbon dioxide emissions into the atmosphere. And as you can see, that blue line goes down rapidly straight away and goes down to net zero around in the 2050s. It's a little bit, you've probably heard of the target of net zero by 2050, but that's accounting also for land emissions. If we just look at emissions from energy and industry, they reach net zero in these scenarios in the 2050s. So that would be a good result if we manage to do that. But what is really interesting here, and what actually people are less familiar with, is the total carbon dioxide that we produce from energy and industry, from burning fossil fuels, from making cement and so on. It doesn't go down to zero. In fact, it doesn't go down anywhere near zero. It goes down by a factor of 2/3 or so. But that big grey wedge is the carbon dioxide that we dispose of back underground, or sequester in the jargon. So we stop global warming in these scenarios in which we manage to meet the goals of the Paris Climate Agreement. We stop global warming with a combination of two things. If we go to the next slide, thanks, Kwame. We burn less by replacing fossil fuels with renewables and so on, solar and wind. Both are renewable sources in which South Africa is particularly well endowed. But in addition to burning less, and this is globally we're talking here, if we go to the next slide, Kwame, we also store more. We get rid of carbon dioxide effectively back into the Earth's crust. The way you do this is you capture the carbon dioxide either from a point source, from a power station, from a factory, from a refinery, from an oil, from a gas processing plant or whatever. You compress it, you first clean it, you get rid of any impurities, you compress it, pipe it to a geological formation, and then re-inject it back underground. Senamile Masango has a question. I'm very happy to take questions as we go along. Did you want to ask your question straight away?
Yes, Prof. Yes, Prof. Yes, Prof. Thank you so much for the opportunity. I understand the model that you just presented, the slide prior to this one, about carbon storage, that we can capture, store, and utilize CO2. However, let me not say however, I want to ask you, Prof, in the world, I'm sure you are more experienced than me, than myself. I've never seen a successful CO2, whether it's captures or store or utilizing project that is successful. Do you perhaps give us an example?
Well,
I never seen it. It's a good concept, but I never seen a successful project on capturing, storing, and utilizing the CO2.
So at the moment, we sequester, we store back in the Earth's crust about 40 million tons of carbon dioxide per year worldwide. That's over a dozen or so large projects and quite a few smaller ones. What do you mean by I'm not quite sure what you mean by successful. It's undoubtedly true that the industry has perhaps overpromised on this technology. So if you mean by success, doing everything that the industry claimed it would do, then I would agree with you. I think in most of these projects, they don't do everything that is claimed of them beforehand.
It's the
But
last
it is,
point, Prof. They
but it
promise
is,
the
yeah,
promise.
yeah, there is a
That promise
tendency.
are not true. So it's not that we cannot go to that route because it's not true.
Well,
Anyway, by doing these things, capture, store, utilize, you're also harming the environment even more. That is my thought on that. Those are my view, that by doing all these three, you are even harming the environment more.
well,
So it's
okay,
better to focus on but those are my view, Prof. So it's better to focus on an energy source that emit lower net zero, and we also have energy sources that does not even emit the CO2. But I don't want to mention that source because people think I'm biased because that is my field. But yeah, that is my take on that, Prof.
No, it's very important. We cannot hope to pump back into the Earth's crust all of the carbon dioxide we're producing. That would be physically very difficult. So that's why, you know, you see very clearly on this diagram in front of you, 2/3 of the solution is burning less. So that's replacing fossil carbon sources with renewables, with other ways of generating energy that do not generate carbon dioxide at all. But there are activities, certain industrial processes in particular, for which it's very difficult to find a fossil. Right now, there is no fossil-free alternative. So for those activities, I guess you have three choices. One is to stop doing them entirely, which generally is very expensive and even politically destabilizing. If you ban activities entirely, people get very, if they're used to having steel and cement available, and you suddenly turn around and say no, it's no longer allowed, then this even could cause unrest. The second option is to continue and to dump the carbon dioxide into the atmosphere. And I would say that's the most dangerous option because it causes continuous climate change. And the third option is to get rid of the CO2, put it back underground. There's no fourth option. So, as I say, we have a choice. We either dump the carbon dioxide in the atmosphere or we put it back permanently underground. I would argue that it's much better, much safer to put it underground than to dump it into the atmosphere. Right now, we use our atmosphere like a giant landfill. We just like or another analogy you could use. 200 years ago, we used to put all our sewage straight into the rivers in the UK, and we regularly had cholera epidemics because we just didn't treat our sewage in any way. It was just dumped. That was unacceptable. The people at the time, they realized what was going on. They realized why they were having their cholera epidemics. And so they simply banned the practice of dumping sewage straight into the waterways and required that the sewage be treated first. It's the same thing. We at the moment, we are dumping carbon dioxide into the atmosphere in the way that 200 years ago we dumped sewage straight into rivers. We have to stop that practice, and we have to find somewhere else to put it, somewhere where it will be safely stored for hundreds of years, because that's the time scale on which it continues to impact the climate. I'm not saying this is the whole solution, but I'm saying it is a vital component of the solution because it's the only way to stop continued use of fossil fuels from causing global warming. So if somebody somewhere in the world is still using fossil fuels, then the only way to stop that activity from causing global warming is to dispose of that carbon dioxide that is generated safely and permanently, either putting it back underground or potentially by turning it back into rock. I mean, that's another option, but it's more an experimental option at the moment, which is actually to turn carbon dioxide directly back into rock. That's the most permanent storage solution, but it's still experimental at the moment. Whereas injecting back into the Earth's crust The industry knows exactly how to do this, and they've been doing it for decades. So that doesn't mean that they can be relied on to do it safely. It would have to be done and regulated very carefully, just like any waste disposal activity has to be carefully monitored and regulated. But the fact that something needs to be regulated is not, and also the fact that it's expensive is not an excuse for not doing it. You know, yes, it was cheaper to throw sewage in the river than it is to treat it properly and to make sure that we don't cause cholera epidemics. But that doesn't mean it's a good idea to throw sewage in the river. It's cheaper to dump carbon dioxide into the atmosphere than it is to store it safely back underground, but that doesn't make it acceptable to dump it in the atmosphere. This is the equation we have to strike. If we go to the next slide. So this is now. By the way, just if you store carbon dioxide underground, it does not cause harm to the environment in the way that it does if it's stored in the atmosphere. This is very, very important for everybody to understand. Carbon dioxide dumped in the atmosphere causes harm. It causes harm to future generations for millennia to come. If we re-inject carbon dioxide back into the Earth's crust, if we do it properly into the right rock formations, it will stay there for millennia, for thousands of years. We know that because we find carbon dioxide in the Earth's crust routinely. So we know that it's possible to store carbon dioxide for very, very long periods of time back in the Earth's crust. But let's come to this point about, which a good point you raise about it being expensive. Yes, storing carbon dioxide is much more expensive, obviously, than dumping it into the atmosphere. That's the sort of free option, but obviously that's because the costs of dumping it into the atmosphere are actually imposed on future generations. They're not incurred by the dumper. But in the short term, this diagram from a recent Goldman Sachs report shows that the cheapest option for most of the carbon dioxide we generate at the moment is to reduce emissions, to reduce the amount of carbon dioxide we produce. So to use alternatives like wind and solar, or to change our industrial processes to make them more efficient, to reduce the amount of carbon dioxide they generate. So that's the red curve here, which is measures to reduce carbon dioxide production. And you'll notice the red curve is below the blue curve for about 2/3 of our emissions. And it's only when we get down to the sort of last 25% or so of our emissions, if you go to the next slide, or just hit return. It's only when we get to that last 25% of emissions that we find the cost of avoiding producing carbon dioxide becomes very high indeed. And these are activities like aviation, like cement production. So two sort of opposite ends of the scale in terms of, there's cement production is seen as an absolute necessity. Aviation might be seen as a bit of a luxury, but these are two activities, examples of activities where right now there is no alternative to generating carbon dioxide. So these are activities in which if you put the the only available option is to dispose of that carbon dioxide underground. It's much more expensive to ban aviation than it would be to dispose of the carbon dioxide that it generates. So we need carbon dioxide storage to achieve net zero. Economically, I would argue we need it to achieve net zero at all, because the storage, without storage, the kind of economic incentives we would need to stop people producing carbon dioxide entirely, the cost, if you like, of a global ban on the production and use of fossil fuels would be so high that it simply won't happen. if you try and imagine what it would take to ban the world from using fossil fuels, you immediately realize that is the most expensive option of all. Imagine the cost of enforcing a global ban on fossil fuel use. I'm not sure I'd want to live in a world where that was even possible. So we need to get there. We need carbon dioxide storage to get to net zero. An interesting question raised, why therefore is the environmental movement so against it? Well, I think part of the problem, if we go to the next slide, is that it's in the short term, it's seen as competition with reducing emissions. It's seen as an alternative to reducing emissions. And it's seen as a way of letting fossil fuel producers off the hook. And indeed, there's a lot of justification for this, because at the moment, most carbon dioxide storage operations in the world are actually not paid for by the industry, but they're paid for by taxpayers. So for example, in the United States, there is a tax break where if you store carbon dioxide underground, you get, in effect, the US taxpayer pays you back your costs. Or in Norway, for example, there's a tax break that's given to the state oil company that requires them, that incentivizes them to re-inject carbon dioxide back under the North Sea. Now, there is it's understandable that environmentalists have a problem with the idea that this fossil fuel industry, which is still perfectly profitable, still making money, should be paid to dispose of its own waste. This should be their problem. It's not our problem. If this industry wants to sell a product that causes climate change, if it's dumped in the atmosphere, then it's up to the industry to find an alternate, safe and permanent way of disposing of that waste product. So this brings us to the idea of a carbon take-back obligation, which is gaining increasing currency in Europe, and I think it would be welcome to sort of start conversation about whether this could be a good way of approaching the climate change problem also in the context of developing countries, which is, so by the way, I just saw, it's interesting actually seeing these comments come in. I haven't talked about nuclear power, but nuclear power is in exactly the same situation as renewables. It's a good substitute for many applications of fossil fuels, but it's not a good substitute for all of them. You can't make cement with nuclear power, for example. You can't fly aeroplanes with nuclear power. So what I'm talking about using carbon dioxide storage for is to compensate for those hard to abate activities where there is no alternative, there is no ready alternative to the use of fossil fuels at the moment. It's important to realize we tend to think of fossil fuels as just energy, but actually less than half of our fossil fuels are actually used just for the production of electricity, much less than half actually. So it's that misunderstanding that fossil fuels are only used to generate energy that's part of the problem we're addressing here. So here's the idea behind a carbon take-back obligation. You place the challenge of dealing with the climate problem squarely back with the fossil fuel industry. So we require fossil fuel suppliers to store a rising fraction of the carbon dioxide generated by both their activities and their products. We know this fraction has to reach 100% if we're to achieve net zero. But one thing is, we also know that different companies may have different carbon storage opportunities available. So the logical way to approach this is to introduce a carbon storage certificate system to allow companies that have cheap carbon storage opportunities to sell them to others to find the least cost, the safest, the easiest ways of storing carbon dioxide in the short term. to build our carbon dioxide storage industry as smoothly and as cost effectively as we can. And of course, all we then have to do is to ratchet up this stored fraction to 100% by a given date, and we get to net zero. That's the argument we have here, is that the way to deal with the fossil fuel CO2 problem is to hand it back to the industry, to require the industry to dispose of the carbon dioxide generated by both their activities and, crucially, the products they sell. If we go to the next slide, we've done some work recently in Oxford looking at the cost of this. So again, if you just compare here the dark blue scenarios, these are the scenarios where emissions are reduced to net zero around or shortly after mid-century, and we limit warming to 1.5 degrees. The right-hand panel shows the fraction of carbon dioxide that's produced by burning fossil fuels that is stored back underground. And if you go to the next slide, you can see that in a smooth transition to net zero by 2050, we should be storing 10% by 2030. Next slide. 50% by 2040 and 100% by 2050. This is just what it takes to get, if you go to the next slide, you can see that's what it takes to move smoothly to 100% storage by 2050. If we go to the next slide, you can see that at the moment, the country that might be closest to this trajectory because of their fortunes of geography and so forth, Norway might be on target for getting to 100% by 2050. The UK, despite its many plans and climate aspirations to be a climate leader, would be only on 2%. And by the way, most countries would be closer to 0% at the moment, because we're not putting any carbon dioxide back into the Earth's crust. We're just digging it up and dumping it into the atmosphere. So one thing we have to do, if you don't, every manager knows, if you don't measure it, you can't manage it. We don't even measure this fraction at the moment. Most countries don't even know what fraction of the carbon dioxide that is generated by fossil fuels in their jurisdiction is put back into the Earth's crusts. So we need to start measuring this fraction, and we need to make sure that it goes up predictably and smoothly to 100% by 2050. Of course, requiring the fossil fuel industry to dispose of the carbon dioxide generated by their activities and the products they sell will make those products more expensive. As I keep saying, it's much, much cheaper to dump carbon dioxide into the atmosphere than it is to dispose of it safely. Just as 200 years ago, it was much cheaper to throw your sewage in the river than it was to process it properly and safely and stop causing cholera epidemics. So, but the implications of a smooth transition are not nearly as frightening as people think. So if we go to the next slide, we already had the comment that carbon capture is very expensive. Well, it's compared to the cost of dumping carbon into the atmosphere, it's not that expensive, in fact. But at the moment, if you can, we already have projects running today which show that you can capture and dispose of carbon dioxide safely and permanently for around $50 per ton. Now, as we progress to net zero, it'll get more expensive per ton of carbon dioxide to get rid of it, because we won't have it being produced conveniently at point sources, because we'll have captured them all. We'll have found all the point sources of CO2, and then we'll be left with having to compensate for carbon dioxide, for example, produced in aeroplanes, where you can't capture the carbon dioxide at source. You'd have to recapture it from the atmosphere, and that's more expensive, maybe costing $250 or so per ton of CO2. By the way, you can already pay a company to capture carbon dioxide and dispose of it back underground for that sort of price. It depends exactly on the contract and so on, and these are still quite small contracts at the moment, so prices aren't very reliable, but you know, it's already a technology that is available and exists. So this isn't something, you know, some hypothetical for the future. What would introducing this obligation onto companies mean for the cost of their products? Well, but if you're only requiring companies to dispose of 1% of the carbon dioxide generated by their products, then it has quite a small impact on the cost of the products they sell, only the equivalent of 50 cents or so per ton of CO2 generated by the products they sell. That would, of course, rise as the fraction you require companies to sequester goes up, and eventually would reach the cost of free air capture around the 2050s. But if we go to the next slide, if you think of that in terms of dollars per barrel of oil, that implies like a $5 per barrel of oil premium by the early 2030s. Eventually, it goes up to a very high premium per barrel of oil by the 2050s, and undoubtedly, if we had to add on the cost of disposing of carbon dioxide, we would use much less fossil fuels because they would be more expensive. But they wouldn't be causing climate change, and we can transition affordably to 100% capture and disposal of carbon dioxide if we just get on with it now and progress over the next 30 years. So this addresses the point of carbon capture and storage looks expensive if you think we have to do it to 100% of the carbon dioxide we generate from burning fossil fuels today. But actually, what we need to do is to get to net zero by 2050. We need to get there smoothly. And if you consider the cost of a smooth transition, it's perfectly affordable. If we go to the next slide, it's interesting that, you know, this is a way of addressing the climate change problem, which it would be remarkably simple because, you know, for example, back in 2015, the UK, as I sort of only partly jokingly say, we nearly solved the climate change problem, although nobody noticed. There was a 2-line amendment to the energy bill that year, which was that they would undertake a consultation on measures requiring extractors and importers of petroleum to contribute to the development of carbon capture and storage. It was sort of very gentle words, but everybody knew the direction they were going here, which was towards this kind of mandate, this kind of obligation on fossil fuel importers and extractors to dispose of the carbon dioxide generated by their activities and products. It was appeared in the bill. It was supported by all 3 parties in the UK Parliament, and then it disappeared again. My understanding is it was removed after some rather violent lobbying by the fossil fuel industry. It's a shame, because if you think about it, if they'd have done that, and if other countries had done the same, we would be well on our way to solving the climate problem by now. But it's not too late. We can still do this. Companies, by stepping up and pointing out that this is possible, could empower their governments to actually take the necessary steps to require the fossil fuel industry to start moving on to a sustainable path. And it's very much in the interests of investors to do this. If we go to the next slide, we've been arguing for some years now in Oxford that anyone investing in fossil fuels needs to be asking some very simple questions of the companies they invest in, not just fossil fuel companies, by the way, but all companies that they invest in. Does the company understand and is it committed to achieving net zero? Most companies now, when we introduced these principles in 2018, this was seen as a bit radical, but now most companies say, oh yeah, we're totally committed to net zero. But I think we have to follow up and say, well, is it just words, or does the company management really recognize what net zero means? Even more importantly, does the company have a profitable net zero strategy? What's their business model in a net zero world? So for a fossil fuel company in particular, what are they planning to do? How are they planning to continue in the business they're in a net zero world? And that's that we still have not. That's a question we haven't really got answered by the majority of the world's fossil fuel companies. We're getting answers along the lines of Shell and BP's long-term scenarios, which rely, as I say, very heavily on nature-based climate solutions to mop up the carbon dioxide generated by continued use of fossil fuels. I would argue that's a good short-term strategy, but it's not going to work past mid-century. If we go to the next slide, this is just that sort of the end of my talk, and I very much welcome questions from you. Perhaps there's a couple of links there which show you where you can follow up on the ideas I've talked about in this talk, most specifically in the carbontakeback.org site, which sort of goes through the implications of a carbon takeback obligation. But I'm hoping, we've already had some questions as I've been talking, I'm hoping there are plenty more, and I'm happy to take them. I think we have another half an hour or so for questions. Is that right, Kwame?
Yes, that's correct.
Great. Okay, so it's over to you now for questions.
All right. I think maybe perhaps we should start with the questions in the chat. I think you've answered the first one. The next question I think comes from Tombi was that doesn't CO2 storage have an impact on the quality of underground water?
Okay, it can do. That's a really important point. So if you store it badly, and you choose the wrong rock formations, then there's a risk of the carbon dioxide leaking and contaminating underground water supplies. However, I mean, you would normally store, it's important to stress, there is lots of carbon dioxide already in the Earth's crust, which has been there for millions of years. So it's perfectly possible to store carbon dioxide safely in the Earth's crust. You just have to, you're not injecting it, a few meters underground where, normally our water supplies come from. You're injecting it kilometers underground, down to the depths where we get hydrocarbons from in the first place. And so if you inject it into the right rock formations, then the risk to the water supplies is minimal. It is worth stressing, of course, we need to build this carbon dioxide storage industry, and so it's not just about the cost of doing it in the short term, but also the requirement to build trust in this industry, to build a coherent regulatory regime to make sure that we don't get leaks and water supply contamination and so forth. Because as we've seen with the unconventional gas industry, if you let an industry develop too quickly, the fracking industry I'm talking about here, if you let an industry like that develop too quickly, you can have problems. And it takes time to develop the regulatory measures you need and there's always a certain amount of trial and error in developing regulation to make sure that you address the potential side effects of large-scale storage. But we're going to need to do this. That's the point. So, we need to be getting on with it in order to build those regulations required.
Okay. I've got a question for you. And it's a question that comes up every time we have this discussion. One of the measures by environmentalists specifically is to stop the burning of fossil fuels, period. That if we're going to meet our climate objectives and protect the environment, we need to stop burning fossil fuels. Unfortunately, some of the poorest countries in the world depend on fossil fuel, one, for revenue, and also two, to provide energy to drive development. Do you think it is fair for there to be that kind of pressure on developing countries, considering that we actually didn't contribute to this problem in the first place?
I absolutely don't think it's fair, which is why I think the idea of a global ban on fossil fuel extraction and use is wrong. It's not just unfeasible, but it would be unethical. It would be very wrong for those of us who've benefited massively from historic use of fossil fuels to turn around and say to developing countries, you're not allowed to use these fossil fuels at all. So that's why we have to develop ways of using fossil fuels that don't result in climate change. And the only option then left is safe and permanent disposal of the carbon dioxide they generate. Now, I think it's very important that, again, countries like the UK that has benefited disproportionately from the use of fossil fuels to date should take a lead in investing in this technology, in improving what works, in establishing what doesn't work as well, to show the whole world how to use fossil fuels safely. And if there are going to be leaks, if there are going to be groundwater contamination problems and so on, those problems should happen in the countries where we've benefited most from using fossil fuels in the past. We should be getting on with this here. One concern I have also is, for example, many people in Europe say, well, Europe's quite wealthy, so we're just going to use renewables. So in Germany, for example, they say, well, we're just going to use renewables. We recognize that it's more expensive to, for example, make steel with hydrogen from renewable energy than it is to make steel using carbon capture and storage. But we don't care because we're rich enough to do it. And many environmentalists think that's the ethical thing to do. I say that's the unethical thing to do, because what that is effectively saying is we push the whole burden of developing CO2 storage onto developing countries. We say, this is your problem. You're going to have to develop this technology. You're going to have all the problems with groundwater and so on, if it happens, in order to sort of get through the teething problems of this new carbon dioxide disposal industry. And I think that's wrong. I think we should be developing this industry everywhere, because everywhere is benefiting, and some parts of the world much more than others, from our continued use of fossil fuels.
I've got one more question, then I'll open the floor again. I think considering that most of the participants here are investors, so financial market participants, I think most people think of climate change, and I speak for myself as well, as unpredictable weather, rising sea levels. What I don't think most people make the connection is that climate change is actually going to impact the productive ability of the earth and indirectly influence the profitability of the businesses that they invest in. And I think the question I'm actually asking is that, is there some work in that field to try and explain to people that, for example, if you're invested in a food company, in 10, 15 years time, you're going to have unpredictable harvests, so you're going to have more volatility in your input cost, and therefore you need to start pricing that risk into your models. Is there any areas where we can get that kind of information, or have you guys done some work in that area?
Yeah, there's a lot of work going on. I couldn't sort of list it all off the top of my head, but the task force for climate related risk disclosure, TCFD, it has done a good job of establishing standards of reporting for companies, that they should start to disclose their climate related risks. And many companies, including a lot of the major food suppliers of the world, like Unilever and so on, have signed up to the principles of the TCFD, and they are actively trying to quantify their exposure to climate-related risks on their books. And so, yes, there's a lot of activity in that area, but I'm afraid I can't sort of list a single source for it. By the way, there is on one of the sources mentioned on this presentation, and by the way, in reaction to one of the questions, I'm very happy for my slides to be shared with the participants. The netzeroclimate.org site contains a whole toolkit that businesses can use to look at the implications of the transition to net zero for their businesses, which would also be of relevance to investors as well. One thing which I think is particularly important for investors is, and where I think investors should be talking to governments about this, is at the moment, anyone invested in the fossil fuel industry, and I think you have to accept that means all of us, even though we might say we're not invested in the fossil fuel industry, it's very difficult not to be invested in the fossil. I'm sure you know this. It's very difficult not to be invested in the fossil fuel industry. If you own an index anywhere, you're invested in the fossil fuel industry. I mean, it's so much part of the world economy. So anyone invested in the fossil fuel industry is exposed to the risk of their fossil fuel assets being abruptly revalued or potentially stranded as climate change risks evolve. And that's a major exposure for investors because we're not developing carbon dioxide storage as fast as we should do. Because if the only alternative to continued use of fossil fuels is to ban them because we haven't developed carbon dioxide capture and storage fast enough, then that would be a very abrupt, cataclysmic revaluation of fossil fuel assets. They would go from being valuable to being valueless overnight. And that's a really bad scenario for investors. So investors should be shouting at their governments to implement policies to ensure a smooth transition to full carbon dioxide capture and storage, rather than running the risk of abrupt devaluation of fossil fuel assets as climate impacts emerge over the coming decades.
Okay. There's a question in the chat, talks about, can you comment on CO2 uses in HO2 extraction? I think it's hydrogen.
Hydrogen.
Yeah.
Yes, I mean, so the cheapest source of hydrogen right now, and possibly for many decades to come, is so-called blue hydrogen, from natural gas. So you take natural gas, you steam reform it, so you get then a stream of CO2 and a stream of hydrogen, and if you and then of course your challenge is to dispose of that CO2, the idea of and of course that's an ideal source of CO2 for sequestration. So if you have a natural gas industry, you can convert it to a hydrogen industry relatively straightforwardly by disposing of the CO2 back underground where the natural gas is coming from. So there's a very logical link between requiring carbon dioxide disposal and the transition to a hydrogen economy. If you had this kind of regulation in place to require companies to dispose of the carbon dioxide generated by their activities and products, they would almost certainly prefer to sell hydrogen so that they can profit from disposing of the CO2 than they would to sell natural gas, and then they'd have to pay somebody else to dispose of the CO2. So it would very clearly incentivize a transition to a hydrogen-based economy.
Just to the rest of the participants, if you want to ask a question, you can raise your hands and we'll recognize you, or you can also type in the chat column. May I ask you, if no one is coming through, can I ask you some more questions as well? So I think one of the things that it may sound like pardon my ignorance, I'm not a scientist, but this question of CO2 versus greenhouse gases. the first question I want to ask is, are all greenhouse gases bad, or is it, which one is the bigger culprit to global warming? And the second point I want to ask is, a lot of data shows that for example, there's more greenhouse gas emissions from agriculture than transport, yet there's a lot of emphasis on transport. Can you perhaps explain why that is the case?
Okay, so I think we do have a problem with the climate issue. It's a sort of variation on the 80% of the problem comes from 20% of the drivers. So it's another 80-20 problem, which is we tend to spend 80% of our time talking about 20% of the problem. So the fossil carbon dioxide emissions of carbon dioxide from fossil fuel use is 80% of the climate problem. So that's 80% of the warming caused so far is due to CO2, and right now the vast bulk of that is due to fossil CO2. So the remaining 20% is of course important. It's 20%, it's not zero. And a lot of it is relatively easy to address. So, for example, methane right now, methane emissions are going up very fast. Methane is a very powerful greenhouse gas. That's most of this new methane production is arising from just leaky pipes or bad management in the natural gas industry. That's ridiculous. I mean, globally, the natural gas industry allows about 3%, I understand, of the methane that we extract as natural gas is allowed to leak into the atmosphere, just as a direct loss. That's, the industry, best practice in the industry can reduce that fraction down to 0.3% or less, so a factor of 10. So it's, that's those leaks cost money because natural gas is a resource. You can sell it. So it's completely crazy that we're allowing methane just to leak into the atmosphere from badly maintained pipes in the natural gas industry. That should stop. It just doesn't make any sense at all. So, but that said, we shouldn't allow the fossil fuel industry to say, okay, we're fixing our methane problem, so we're done. We're not, we're discharging our climate obligations by fixing the methane leaks in our pipes. No, they should fix those leaks anyway. And it's in their own interest to fix those leaks. But we should also recognise that even the most we can do acting on global methane sources, it might reduce global temperatures by perhaps 1/10 of a degree or so by mid-century. So again, it's that 1/10 of a degree, and you've got to put that into the context that we are currently driving up global temperatures through fossil fuel carbon dioxide emissions by 2/10 of a degree per decade. So yes, it'll help, but it's only a few years of fossil fueled warming.
Okay. There's a question in the chat. It talks about Nigeria. It says Nigeria has a lot more gas reserves than it has in oil, and it wants to sort of industrialize by using gas. What are your thoughts, or what advice you have for policymakers in this regard? And what are the challenges?
I think there's a great opportunity there, and industrialization through gas is easier to decarbonize than use of oil, for example, in transport, because you can go straight to hydrogen as an energy vector and get rid of the CO2, and indeed you can use the CO2 as part of the natural gas extraction process. You can re-inject CO2 into natural gas reservoirs in order to increase the efficiency of the extraction of natural gas. CO2 is denser than methane, so if you inject CO2 into a natural gas reserve, it flushes out the methane. So that's a potentially quite a valuable resource. This comes back to the idea of carbon takeback as a regulation, if that regulation were in place, then there would be an incentive to companies based in Nigeria to get rid of carbon dioxide, so that, for example, they could sell carbon storage certificates on perhaps a global market in order to companies like Shell and BP, who might need those carbon storage certificates in order to have a license to continue to sell oil in other countries. So this is a way of, distributing the cost of decarbonizing, from countries which have good carbon dioxide storage capabilities and capacity through sort of luck of geology. Some countries may have great capacity for getting rid of CO2. So if they can offer that service to the world, that's great. The world should pay for it, and we should just get on with it. And this is why a global market, but it would need to be a tightly regulated market, because of course you need to be sure that the CO2 really is being disposed of. So building that regulation and trust is essential here, but it definitely represents potentially an opportunity for many countries to enter this carbon storage industry, because it's an industry we're going to need to build.
Okay. Tapelo, you're recognized.
Thank you. Thank you, Kwame. Prof, thank you for your insights. You made mention of a TCFD, and I will not begin to try and outline what that acronym stands for, but I will certainly research it. Now, what you mentioned is that it obviously is developing some framework for disclosure by companies to start showing their climate commitments, I guess. But now, have you seen any research at all that perhaps may begin to suggest that financial markets are actually beginning to price in the impact of climate risk?
Well, the finding in that Dutch court against Royal Dutch Shell, I believe, had a material impact on the share price of Shell. So if you like, it affected the value of my pension. So there you are. It affected me. I mean, not very much, but it's because I'm sure my pension is a little bit invested in Shell. Everybody's, in the UK at least, everybody's pension is invested in these big companies. So I think and indeed so there's two sides of risk. Of course, there's the impact risk, and there's the stranded asset risk. So if a company like is a food production company, or which might be vulnerable to droughts or extreme weather, then or infrastructure, or if it's real estate assets that, again, whose value might be affected by flooding and so on. That's one class of risks, which I think the financial markets are actually getting better at pricing. So although there's many distortions, I mean, I think even now in the United States, you have subsidized insurance for beachfront properties in Florida. So that makes the market, that really undermines the market, because of course it makes it look as though investing in beachfront property in Florida is free of risk, when actually there's a major risk from hurricanes, and it's one which is increasing. So, but I think the markets are getting better at pricing in that impact risk, and I think they're beginning to price in the so-called transition risk. This is the risk of things like fossil fuel assets being abruptly devalued as a result of emerging impacts of climate change, suddenly requiring meaning that the operators, they lose their license to operate to extract and sell those fossil fuels. I think the big transition over the next decade will be a greater recognition by the markets of transition risk. But I do think this, it's always hard to tell what it is that drives valuations of companies. But I can't help thinking that the price earnings ratios of fossil fuel companies are remarkably low over the past few, given the sort of reliable source of dividends they've been, their stock prices are not as high as you might think they would be, particularly in times of great financial uncertainty. And I imagine there's an element there of transition risk being priced into the valuations of these companies. These companies, their value is based on their assessment of their fossil fuel reserves. They say we've got this many reserves that we can exploit, and this sets the value of our company. Well, if they're not allowed to exploit half of those reserves, then obviously that affects the value. Can't hear you, Kwame, I'm afraid.
Yeah, you muted, Kwame.
Sorry.
Yeah, there's another question, and I think it relates to attribution. So the question that Opa is asking is that, is there a way that we can actually quantify the amount of emissions produced by individual parties or corporations, so that at some point in the future they can be held accountable for both historical and current emissions?
So, and that's a really interesting question, and in principle, absolutely yes. Partly because of that very simple relationship I showed you early in the presentation, that straight line relationship between carbon dioxide and temperatures. It means if you put a ton of carbon dioxide into the atmosphere, it has a certain impact. It doesn't really matter what's happened before or what happens afterwards. You put that ton of carbon dioxide into the atmosphere, it drives up global temperatures by, if you want to know the number, it's about 0.5 trillionth of a degree. So although that doesn't sound very much, we are putting carbon dioxide into the atmosphere at 40 billion tons per year. So if you do the math, that translates into almost 0.2 of a degree per decade, hence the sort of 0.2 of a degree per decade I was talking about earlier on. So there's a very predictable relationship between dumping carbon dioxide into the atmosphere and rising global temperatures. Now the next question, of course, is what's the relationship between rising global temperatures and actual harm? Because, a 0.1 of a degree increase in global temperature doesn't itself directly cause harm. What it does is it changes the probability of different weather events, droughts, heat waves, rainstorms, and so on. And these are the ones that actually cause harm. Now, the science linking rising global temperatures to the risk of extreme weather events is actually getting stronger all the time. It's a new science, relatively new. It's been developing over the past 15 years, but we are getting to the point now where we can quantify the contribution of greenhouse gases to individual instances of extreme weather. And yes, following on from that, there is the potential for accountability.
Okay, I don't see any more questions. Perhaps I can ask you one more, and then we can wrap up. We haven't spoken about hydrogen. I think you talked about it slightly. I mean, I've seen that, for example, if you're watching the Olympics, the Japanese have been pushing hydrogen quite substantially as an alternative form of fuel. What are your thoughts on that? And what's the viability of hydrogen as a general form of energy source?
I think hydrogen is interesting because it is a way of decarbonizing fossil fuels themselves. And our most successful climate policies are decarbonization policies, not bans. One thing I like to point out to people is, we didn't save the ozone layer by banning deodorant, or even by rationing deodorant. We saved the ozone layer by coming up with different aerosol propellants, by replacing CFCs with something else. So we need to do the same thing for fossil fuels. We need to decarbonize fossil fuels. We don't want to ban them. but we need to find ways of using fossil fuels that don't result in carbon dioxide being released into the atmosphere. And hydrogen plays a very important role there because it can act as the energy transportation and storage vector for a decarbonized fossil fuel industry. So that's where I think hydrogen actually has a very important future role to play. I noticed there's some more questions appearing in the chat as well. So.
Yeah.
They appear and disappear quite quickly on my screen. So.
Yeah, this one just says, how many trees do we need to grow to absorb CO2 emissions meaningfully? I think you addressed that earlier on.
Yeah, a little bit. And I think it is an important question to bear in mind that, you know, at the rate we are producing carbon dioxide at the moment, I think we need sort of one France every year or something. I mean, there's, you know, the area we would need to reforest is so large that it's impossible to simply compensate for our continued use of fossil fuels by planting trees. And the other important thing is, if you plant a tree, it takes up carbon from the atmosphere while it grows. So for the first 40, 50, maybe even 100 years, depending on the type of tree. Assuming you don't cut it down again, of course, if you cut it down again, then the carbon is put back in the atmosphere. So that's like, you know, it doesn't really achieve anything. Even if you leave it there, though, it stops taking up carbon dioxide. So it helps for a few decades, but it doesn't compensate for the permanent impact of continued fossil fuel use. So we just have to recognize that it's a good resource, but it's a finite resource. It's a limited resource. It's one we should use, but we should be realistic about how much potential it has.
Last one. This is the last one, and then we wrap up. No more. That's actually a good question, and that's why I'm actually asking. It says, to what extent can we expect this energy transition to be inflationary? I.e., to what extent do we expect it to increase costs?
So I think that's a really important point, because you know, I put on my slides, I pointed out that enforcing 100% CO2 disposal with the technologies we have available today, of course we might get it cheaper, would potentially double the price of oil. So now that would be inflationary, undoubtedly, you know, a sort of, but if it happens slowly, and as a result, economies adapt to the higher price, it doesn't need to result in a permanent, it doesn't need to have a permanent inflationary impact. So, you know, the price of oil did double in the sort of between the 60s and the 80s. It more than doubled. It went up by, I don't know, a factor of 4 or something. And yes, as a result, we had a period of inflation, well, for other reasons as well, but we then controlled it, and the economy adapted to the new price of oil, and you know, dealing with that new price of oil is something the world economy is now accustomed to. So that's going to have to happen again, and because we cannot, you know, the alternative of just allowing carbon dioxide to accumulate in the atmosphere and threatening food supplies and all the rest of that would be even more inflationary. So we need to fix the problem. Fixing the problem will make the use of fossil fuels more expensive, so it will affect the prices of many products. But if it happens smoothly over 30 years and not in a big panic in the 2040s, then we can manage the inflationary impact. But it is very important to keep that under review and make sure that, again, we plan this transition.
Okay. I think we've exhausted our time. So thank you, Professor Myles, very much for joining us. And we also thank all our participants. I hope they found the lecture and the discussions that followed quite useful and engaging. As we said earlier, we at Longmark pride ourselves in trying to bring the very best in the relevant industries to try and be at the cutting edge of the discussions on key topics that affect investors. And we hope we achieve that objective with today's lecture. So we've recorded the series, so anyone who wants a recording, we can make that available. And Professor Myles has also said that he's happy for us to share his presentation. So anyone that wants the presentation can reach out to us and we can distribute a copy. So once again, thank you everyone and enjoy the rest of your day.
Thank you, Kwame, and thank you, Prof. All the best.
All the best, everybody.
Thank you.
Yes.
Thank you.
Thank you.